Hi, everyone. Thank you for joining the call today. The purpose of this demonstration is to go over AtScale's new virtualization capability and introduce those to our enterprise data and analytics solution. For those of you who are unaware of the AtScale solution, we represent a vast number of blue chip Fortune 2000 organizations globally. As you can see here, we have customers across all verticals, and typically these customers entrust AtScale with their business to overcome 4 challenges associated with data and analytics consumption in today's world. To start, AtScale is going to help accelerate data-driven decisions at scale, and Phil will explain to us how we're able to automate a lot of the engineering necessary to deliver insights quicker to your end users. Second, we're going to control complexity and costs of analytics. Through a number of means, we're going to introduce predictability and lower the overhead typically associated with self-service analytics in the enterprise. Third, we're going to help deliver one consistent and compliant view of business metrics and definitions. Essentially, we're going to give you one consolidated workspace to build your models and consume across a number of BI tools, pulling from multiple data sources as well if the use case calls for it. And lastly, we're going to mitigate risks associated with data and analytics. This ties into a number of different measures taken with AtScale. Mainly, we're going to eliminate extracts and again, encourage collaboration and consolidation of these metrics and definitions across the enterprise. So with this, I'll pass the ball over to Phil to explain the architecture and show you the interface.
Thanks, Brendan. One second, just switching over the screen. So this is essentially how AtScale works. AtScale works as a broker for all the data requests that are coming in. So you have your analysts or your data scientists, whoever's consuming data, come in through different types of interfaces, whether that's an Excel report, some dashboard in Tableau, or an API endpoint. And essentially, AtScale captures that information based on a model that has been created within AtScale, typically by a data engineer or a data modeler. AtScale will then utilize that information to be able to send the queries back to the underlying sources. And so in this particular case, you may have multiple sources. So for example, Oracle, Teradata on premise, Google BigQuery, Snowflake on the cloud, maybe some remote data source that's even in somebody else's VPC that you've connected to. At the end of the day, what AtScale will do is it'll determine whether or not to go to the underlying underlying database's source table or an aggregate that it's built for it. And by that meaning that AtScale has this technology called autonomous data engineering, what essentially tries to mimic the sort of functionality that somebody would do as a data engineer. So for example, building an aggregate for faster consumption of data versus having to pull a massive 100 terabyte table. And that's the beauty and the value proposition of AtScale is really here, where you're eliminating the need for manual work when it comes to preparing tables for fast consumptions and for multiple consumptions from different data sources, so that an analyst can actually get to the data without having to know where it sits or having to wait for long queries to finish. With that being said, I'll move over to the AtScale interface. This is the AtScale interface. It is a web interface. Right now I'm logged in as an administrator. As you can see, I have a number of different cubes that I have created, some that are virtualized across a number of different sources, which we'll cover today, but also just direct cubes over to BigQuery, Snowflake, Redshift, and this one's actually to Snowflake as well. As I look at what's in this cube, you'll notice that in the cube, and we'll go into our model. When I go into the model, you have a number of different sources in this model, and I'll just maximize this real quick. And you'll see that this one comes from Redshift. So this is our fact table, our source table. Well, this one comes from Snowflake, which is the order dimension, which is comprised of a dim order. And in the cases of other dimensions, you could have actually a number of different tables connected like this one, which is multiple sources going over to BigQuery in this particular case. So the way that somebody comes in and adds a table into AtScale would be to go to your data sources on the right-hand side. You see that I have my 3 data sources connected, and I'm able to just simply come in and drag whatever table I need into here and say that I wanted to add something from a new table from this adventure data set. I could essentially just come in and drag that. And then I can connect that with a relationship over to another table, say in Snowflake and BigQuery or Redshift. I'm going to remove this table as is not necessary for this particular model. What I will do is I'll show you guys how this connects from a consumption layer, and then we'll go into the query real quick so you can see what's actually happening behind the scenes. So if I come back to my AtScale interface, as you noticed here at the bottom, there's also all the published cubes. So if I were actually to log in as a user, and there is a user view of this, and users don't have to come here, but there is a user view, they would only see these the information here for the cubes that they have access to. And when they click on that, they would get essentially the published cube that you're looking at, and you would get a number of different tabs. One of them explains to you what's in this particular cube. So for example, what are some of the sales metrics? And another one, how do I connect to this particular cube? So if I look at here, you have a number of different ways of connecting: JDBC, MDX, and ODBC and SQL. MDX being for Excel. So we are the only solution in the market out there that enables you to connect from Excel to all the cloud sources, utilizing the cube-like mentality. So you can actually do pivot tables or essentially live connections in that SSAS type of workflow using Excel, even though the underlying source of data can be any of our supported sources. We take care of the translation for you. In this case, I'll show you guys 2 different connections, one in Tableau and one in Excel. I'm gonna go ahead and click Tableau. Notice that AtScale automatically pre-builds the TDS file with the necessary connections so that the users just need to click on this TDS file that got downloaded here. Tableau will launch. And that TDS file tells Tableau where to connect to. In this particular case, I'm using my credentials for AtScale. That being said, if we were connected to LDAP or Active Directory, you would have the ability to then authenticate through the enterprise methods. As you can see here, now we've got our typical Tableau interface. Our dimensions and measures are on the left-hand side, very organized in a very business mind logical fashion. So you don't have to expect users to know where to find things. They're all here at the left for them. And I can start querying my data. So I can come in to click on sales amount, order quantity, maybe throw some product attributes here. And when I do this, you'll notice that my dashboard starts building. It's querying the database. We'll come back to AtScale in 1 second just to show what it's actually doing here. But essentially what AtScale is doing is just merging all those particular things. And I'm just gonna give it a little color. Now, what I wanna show what AtScale did in the back end. And if we actually come back here, I'm going to go to the queries that are coming in. So I click on queries. Notice that there's a bunch of queries that just came in a second ago. So today being February 26th, 10:12 a.m. And you'll notice that there's a bunch of queries from the user admin, right? If I click on admin, so I'm gonna go ahead and hit user, apply data set. I'm only gonna focus on the queries that are pertinent to the request that I made from Tableau. So it's basically these ones here. And you'll notice that this came in from Tableau in a very straightforward SQL fashion. AtScale decided what to do with that in our query planning stage. And in that particular query, it knew that it could get that information just from Redshift. So it went just over to Redshift. Now, if I look at some of the other queries here, like this one, you'll see that this is actually another very standard query from Tableau. Now you'll notice that the query planning stage changed a little bit, and it's now gone and done a bunch of different things. So it's gone to our compute layer, which is a virtualization layer. And you'll notice that this is actually using Spark language. So we use Spark in the underlying, as in the underlying engine for virtualization. And it went and got the information from BigQuery in this particular query. It got the information from Redshift in this one. And basically it came back and sent this, and sent this back to AtScale to be able to create whatever it needed to do and send the information back to Tableau. When I look at what that looks like from an actual architecture perspective, you'll notice that I have a worker. So this is a small cluster. And this is how this is where our Spark cluster actually sits. So we have a supervisor, a listener, and a worker. In a more enterprise deployment, we would have n number of workers. So you could have, 150, whatever makes more sense here. And this is where all the workloads would go. So when essentially data is or the request comes in from Tableau, AtScale uses Spark to be able to decide where to go and get that data from the underlying connections. It does all the necessary transformations and mergings on Spark in memory, and then provides that information back to the user. In the end, what it does is it also goes in and saves that information back as an aggregate that it can use in the future. And so that's one of the beauties of this is that once it's actually done that merge, it'll dictate where to save that information. I don't have that turned on here, but it'll dictate where to save that information so that in the future it can actually look up that same combination of data sources without having to query the underlying source tables. Now, finally, the one last thing that I will cover is how would somebody go in and query the same database or the same data query by using Excel. And so when I click here and I do a connect, I'll get my information from, this time I'll get my string, my MDX string from the Qlik page. I'll go over to Excel. In this particular case, I'm using Excel over with, in Windows. Microsoft has chosen not to include the SSIS drivers with Excel and Mac, so it only works with Windows, and that's a Microsoft decision. But as long as you have access to Excel for Windows, you can come in here and essentially come in and look at Get Data. You'll notice that we're going to click on From Analysis Services. And again, this is because AtScale serves as an alternative to analysis services. The only difference is that AtScale provides you the ability to query not just SQL Server, but all the other underlying data sources that I just covered. And as you'll see here, I'm going to essentially have access to the same queue. So I'm going to look at the virtualization queue, which is the one we're looking at. And now when I bring this over here to the right-hand side, I'm going to start building that pivot table. So I look at sales metrics, and I look at sales amount, and I look at order quantity. Just have that run for me in order quantity here. And now what you're seeing is that AtScale or Excel is communicating directly with AtScale. So this is a pivot table on a live connection over to what it thinks is SQL analysis services, but at the end of the day, it's actually going over to AtScale. You'll notice that there are two new queries coming in as the admin user. In this particular case right here, these very simple queries. What I'll do is I'll open one of those up. And as you can see right here, this is MDX. So this is actually coming in as an MDX request from Excel. Excel, Power BI, all these MDX tools will be able to connect to AtScale. We'll be able to connect to data sources such as BigQuery, Snowflake, Oracle, Teradata, you name it, anything we support. And they'll be able to do it in MDX language, which is the preferred language for those particular tools. AtScale will take care of the translation in this particular case, choosing where to get that information from Redshift. And as I mentioned before, this time, because we just pulled that data, it will actually go and get the data from the aggregate. So it no longer has to go and get the data from the source table. And that's when you start seeing the cost savings that'll come to you as a user or as an organization, because you're now no longer having to go and do a large scan of rows from a large table. You can actually use the aggregate that's been created, that in this particular case only has one row because it only needed to respond to something as simple as a sum of sales amount or order quantity. Hopefully that was useful. In summary, we covered a bunch of different things, including how you would access AtScale, what different interface you can access AtScale through, how those interfaces get, or those requests from those interfaces gets translated via the model that you've dictated to go to the underlying sources, regardless of where the source sits, how many sources feed the model, or whether or not your tool is able to access those sources without AtScale. AtScale takes care of that, being the broker in the middle and enabling your whole organization to have faster and more complete access to your data in all your enterprise data sources.